Now we need to learn about pure functions and something we call referential transparency. Now you've already been using referential transparency, I have no doubts, in your day-to-day jobs. However, understanding the concept often differs from what we understand as something being called. Now it might be that you've already written lots of pure functions and haven't really known that those are pure functions which also adhere to specific rules. Now a pure function is something that we're going to cover in this video by making some simple calculations. But before we go any further, we need to understand what is a pure function. Now first we must satisfy the rule of referential transparency, which simply means that a function only depends on its input. Given the same input, it will return the same output. Similarly, it means that the function cannot depend on any mutable state or any state inside of the function or reference any state outside of the function, keeping things nice and pure. Now the second rule to a pure function would be side effect free. Side effects include your console logs that we use, perhaps reassigning a variable or mutating an array perhaps from outside of a function, or even mutating an object, or also injecting things into the DOM would be considered impure because it has a side effect. The side effect being it has a knock-on effect that after that function is called, something else happens because of that function call. Now to put that into better terms, what we're going to do is, using our new knowledge of what is a pure function, we need to adhere to the referential transparency and side effect free rules. So to do that, we're going to do the opposite. We're going to create a total function, but I'm going to call this the impure. And when I started writing JavaScript, this was how I would develop my code as well. And this typically involves referencing variables and things elsewhere, and our function becomes much more difficult to reuse. It becomes more difficult to test. We're relying on perhaps an items array above, which I can demonstrate momentarily. So if inside our function we added a console log, that actually is a side effect. Running the console code is a side effect. By default, this is an impure function. If we remove it, it can become a pure function if we wish. However, for the moment, we're going to just keep our console log because we're going to reduce our items. We're going to reference our items from the scope above and then simply reduce it based on the price property. Now reduce gives us the previous and the next value, which I'm going to just call x and y. And using a lambda expression, we can say x plus y dot price and pass in 0 as the first argument. Now what we can do underneath is call our impure function, and in the console we can now see 897. So that is our prices which have been array reduced. Using the dot price property, we use an initial value of 0 and we then reduce to a final numeric output of 897. Now this is not a pure function because our items.reduce lives inside a console log for one, so what we could do is remove that. However, we're not passing our items in as a function argument where we could access it like this. If we were to do that, that kind of makes things pure, and we'll not skip ahead for now. Now to make this even more impure, we're going to use document.querySelector, and we can pass in our app, and we can just say .innerHTML equals array reduce. So we can save this out, and you can see that we have the number been injected into the DOM. So again, it's impure because we're referencing our variable of items. We're not passing it in as an argument. And remember, one of the rules of a pure function is given the same arguments, we get the same output, which this really is not the case because this DOM node might not exist. We're also referencing this document. How do we get given the document? And that's via the DOM APIs. Not only this, we're referencing items outside of the scope. So this is very impure way of doing things. So now we've learned the impure way, how could we do better and stick to our referential transparency? Just as a side note, the opposite of referential transparency would be a referential opaqueness, which is exactly what we're doing here, where the dependencies, if you will, are not available in the current function or as passed in as arguments. So here we're going to create our get total. Instead of impure, this is going to be a nice pure function for us. Now what we're going to do is then take our value. Instead of having a body of a function, we can just simply do value.reduce, and we can grab that x and y and the 0 from our initial function above. Underneath, we can get the total pure, call the function. However, before we save things out, we need to pass in our value, because here we're expecting a value. If we don't pass in a value, we cannot reduce over our array, because the array, which is this, the v for value, doesn't exist. So what we can do is just pass it in, and this line of code gets called. Now there's a nice little trick that we can use with a console log. We could say v, and we can use a pipe. So what this will actually do is log out the array for us, and then run our piece of code. So we can actually see that that value is coming through. This is a nice little trick for ES6 arrow functions. Now, because we are returning a reduced value, we could now console log our get total pure, save this out, and we now have the value in the console instead of the DOM. So at this point, we can comment out our impure approach. I am going to take our inner HTML function call. Now, instead of using document inside of the function, we want to keep the function nice and pure. I don't know about you, but this is very easy to test. We just have a simple reduce function, which expects an array, which has some kind of price property inside each object that we're just going to reduce to a single value. So it might be that we do the DOM manipulation outside of any functions. So here we could say equals, and instead of console logging that number, we can instead simply assign it. We can save things out, and we now have 897 in the DOM, and we've refactored from an impure to a 100% pure function approach. The other good thing with this pure function approach is our get total now becomes completely pure, but we've also in fact created a lambda expression. So you can start to see how these concepts are now tying in to the functional programming paradigm. We'll have a quick recap. We take our array, we pass it into our get total pure function call, and because it's pure, we could use it as many times as we like, and we still get the same answer. In the impure version, we simply referenced it from above, so we were actually creating an impure function by referencing a variable outside of the current function scope, as we did with the document as well. So that's it for this video. To sum up, we have pure functions which abide by the referential transparency rule, which we know as a function that, given the same inputs, will always give us the same outputs. It basically implies that our state, which is our items, is passed in, not modified, and that the function that we're passing it into doesn't mutate the state and it has no state of its own. We've also talked about reducing side effects and keeping our functions pure by keeping DOM manipulation, for example, outside of the function and avoiding referencing variables in other scopes, such as the parent scope here. With pure functions, this is what we're going to be dealing with a lot in functional programming, and we're going to be composing lots of pure functions to achieve things like function composition and much more as we progress through the course. So that's it on pure functions. I hope you enjoyed the video, and I'll see you in the next one.